Okay, welcome back. This is part 2 of chapter 10. As we had finished solving this example for the experimental probability, I just wanted to make a note that this can be reduced. And you can reduce it down by 3, and you get 49 over 100, or 49%. So you might want to add that to example 1 since it was not completed. Now we're moving on to example 2, but before we do, we have theoretical probability. And this is still a continuation of 10.3, so go ahead and continue your notes. We just finished experimental, and now we're moving on to theoretical. Theoretical probability is the ratio of favorable outcomes to total possible outcomes. I want you to pay attention. This is in theory. You're not actually conducting the experiments or trials. You're going off of ideally what it should be. So here you have the probability of an event is the number of favorable outcomes divided by the number of possible outcomes. Please pause and write this down. For example 2, I want you to find the probability of rolling an odd number on a number cube. Now, in the example above, we did an experiment. We conducted 300 trials, and we found that rolling an odd occurred 49 out of 100 times. Well, that's 49%. In theory, we have 3 out of 6 ways you can roll a number cube. So this would actually be a 1/2 chance of getting an odd number on a number cube. So in theory, it should be 50%. However, as you can see from example 1, sometimes when you conduct experiments, the experimental probability is close to the theoretical, but may not be exact. Okay, let's move along with lesson 10.4. Open your books to page 422. This is on compound events. First, I'd like you to write down the definition of sample space. The set of all possible outcomes is the total sample space. So here I want you to think, for example 1, about making a pizza. Here are your options. You have 2 options for the crust. You can have a thick crust or a thin crust. And you can have 4 different styles of pizza: Hawaiian, Mexican, pepperoni, and veggie. One option is to create a tree diagram. And when you create a tree diagram, you start with the 2 options for crust. You have thin and you have stuffed. Please copy the tree diagram. I'm okay if you want to abbreviate T for thin or S for stuffed. That's fine with me. Now, in a thin crust pizza, you have 4 different styles you can make. You can make thin Hawaiian, thin Mexican, thin pepperoni, and thin veggie. Or you can put these together here and you'll see there are 4 possible outcomes with a thin crust. The next option is your stuffed crust. Again, you have the same styles: Hawaiian, pizza, Mexican, pepperoni, and veggie. When you put the stuffed Hawaiian, that's 1. Stuffed Mexican, that's 2. Stuffed pepperoni, that's 3. And stuffed veggie, that's 4. So your total possible outcomes for thin and stuffed crust with the 4 options, 4 plus 4 actually gives you your total of 8 possible outcomes. So method 1 is called a tree diagram, and you notice they have the little branches pointing to every option, so it looks like a tree. Method 2 is called the fundamental counting principle. And here, you notice the crust was either thick or thin, so that's 2 possible outcomes. The style is Hawaiian, Mexican, pepperoni, or veggie, and that's 4 possible outcomes. The fundamental counting principle says you can multiply the number of outcomes to get to your total. So all you have to do here is multiply 2 outcomes by 4 outcomes, and you get a total of 8. We get the same answer, but this fundamental counting principle will save you a lot of time and a lot of steps. Once you have that written down, let's move on to lesson 10.5. This is on page 430. There are a total of 7 sections. So make sure you follow along. And if you have any questions, we can go over them on Monday. So 10.5 is on independent and dependent events. An independent event is when two events where the outcome of the first event does not affect the outcome of the second event, they are completely separate events and they do not affect each other. So for example, you can have a spinner and flip a coin. Whatever you spin on the spinner will not affect what you flip when you flip a coin. They are completely independent of each other. Make sure you write down the definition and pause the video if you need more time to copy it down. Once you have your definition written down for independent events, let's go ahead and try to solve this. You spin a spinner here, like the flower, and then you flip your coin. We need to find the probability of spinning a 3 and landing on tails. So there is one way to spin a 3. So one way to land on 3, and that's our numerator here. Now, if you look at this spinner, there are 5 separate sections or total outcomes. So the probability of spinning a 3 is a 1 out of 5 chance. On a coin, you have a 1/2 chance of landing on tails. One side is heads, the other side is tails. So there's 2 outcomes, but only one outcome can land on tails. Now, to find the probability of this compound event, compound means 2 or more. Since there are 2 events here, you multiply the probability of the first event times the probability of the second event. So you just multiply the fractions. Numerator times numerator, 1 times 1 is 1. Denominator times denominator, 5 times 2 is 10. So there is a 1/10 chance that you will land on a 3 and flip tails. Now, the next vocabulary is dependent events. And this is the opposite. This is where the probability of the first event does affect the probability of the second event. So in this case, think about drawing tiles. If you had number tiles, for example, like the one here, you have these number tiles, and first you pick a 5, and then you remove it from the pile. So we draw a 5, and we don't put it back. We take it out. Now, when we drew the 5, there's only one way to land on 5 out of 1, 2, 3, 4, 5, 6, 7 total outcomes. So this is a 1 out of 7 chance of picking a 5. Once we remove it, we cross it off. We cannot count that tile anymore. Now there are only 6 tiles left. The probability of landing on a 6 is 1 out of 6. Now, since it's a compound event, we need to find the probability for both. So we put the probability of both events is the first event, 1/7, times the probability of the second event, which is 1/6. 1 times 1 is 1, and 7 times 6 is 42. So there's a 1 out of 42 chance that you will pick a 5 first, and then you will pick a 6. Okay, 2 more sections to go. 10.6 is on samples and populations, and I'd like you to turn to page 442, please, to follow along. An unbiased sample, that's our first vocabulary word that I need you to write down. An unbiased sample is a random sample that represents a population. Unbiased samples are fair. They represent the actual population. So it's a good reflection of what the population represents. On the other hand, a biased sample does not represent a population, and one part of the population is favored or it's misrepresented. We're out of time for this part, so we're going to pause again, write down the definitions, and then we will pick up the next part for lesson 10.6 and 10.7. Thank you.